So since we have three options, so there are going to be three branches. Every option represents a branch, and the choices are represented how forward we are going. So for the first draw, for the first item that we remove, we have three choices. It can either be a red, or it can be blue, or it can be yellow. So that is the first choice that we have. It can either be a red, or it can be blue, or it can be yellow. So that's the first choice that we have. Now we have removed this. So the probability is going to be 6 out of 15, or it is going to be 5 out of 15, or it is going to be 4 out of 15 for the first choice. Okay. Now the second choice. Now, if the first one was a red, the second one can either be a red or a blue, or it can be yellow. So this is the second item you're removing. Either a red or a blue or a yellow. Okay. Now, in case if the first one was blue instead of red, then again we'll have three options. So it can either be a blue or a red or blue or yellow. So this can be red, this can be blue, and this can be yellow. Then we have third one. If the first one is yellow, it can again either be a red, it can be a blue, or it can be a yellow. So the options that we have is red, blue, yellow. So this is what the tree diagram is going to look like. And if you find the probability over here, this is going to be, you have taken red, so the second one is going to be 5 by 14. If you have taken a red, the blue option is going to be 5 out of 14, because there are 5 blues and no blue has been removed. Yellow, there are 4 yellows, so 4 out of 14, because one item has removed, so it will no longer be 15 item, 14 item. Now if you remove one blue, so again it is going to be 6 by 14. No red has been removed, only one blue has been removed. In case of blue, one blue has been removed, it will be 4 by 14, because one blue has been removed. In case of yellow, again it will be 4 by 14, because no yellow has been removed. Now if you remove one yellow, the second one is going to be 6 by 14, because no red has been removed. In case of blue, it is going to be 5 by 14, because no blue has been removed, only one has been removed from the total, so that's why it's 14. And in case of yellow, it is going to be 3 out of 14, because one yellow has been removed. Now let's take a look at all the possibilities. So the possibilities can be red and red, blue and blue, yellow and yellow. So there are three possibilities for same color. So if we go on to the other one, this is going to be red and blue, this is going to be red and yellow. So this is red and blue, this is red and yellow. Then again this is going to be blue and red, so this is going to be blue and red, and this is going to be blue and yellow. And then this is going to be yellow and red, and this is going to be yellow and blue. So this is yellow and red, and this is yellow and blue. So this is how it goes. These are all the options. Now if the question was find the probability of same color, so same color means it's going to be either red and red, or blue and blue, or yellow and yellow. So that is all the permutation that we need. Now the question is probability of different color. So if the question was probability of different color, now is the question, can we consider it to be the same as not same color? So let's see what are the options for different color. So different color is red and blue, red and yellow, blue and red. These are all different. Blue and yellow, yellow and red, and yellow and blue. So yeah, we can consider them to be not same color, because same color is red and red, blue and blue, yellow and yellow. And if we remove these three from the total probability, it is much easier than to do this math, than to think about all these 6 permutations. So I would rather go with not same color over here, because we can. Because in this particular tree diagram, we can consider different color to be the not same color. So this is going to be 1 minus probability of same color. So this is much easier to do in this way. So whatever calculation we can get over here, same color, we can just subtract it and we'll get a different color, meaning not same color. Now if the next question was find the probability that it has at least one yellow. Now at least one yellow, if you take a look at the option, we have this one, red and yellow, and then we have the permutation yellow and red, then we have blue and yellow, and we have the permutation yellow and blue. So there are 4 options, and we cannot do this by the NOT rule. We have to individually write out the permutations. So red and yellow and the permutation yellow and red, then blue and yellow and its permutation yellow and blue, and these are going to be the only permutation that we have for at least one red. And if we do the calculations, it is going to be red and yellow is going to be 6 by 15 into 4 by 14, 6 by 15 into 4 by 14. So that means we have 2 permutations, each permutation has the same probability, so into 2. Or blue and yellow is 5 by 15 into 4 by 14, and we have 2 permutations into 2, and that is going to give us the answer for at least one yellow.